This talk I've titled Once Around Orion's Belt, and this is a photograph of the Orion Nebula, the most famous cloud of gas and dust in astronomy probably, and much photographed. Everybody can easily find it because it's bright enough to see even without a telescope, and makes a very attractive picture. And this telescope my father will recognize because he helped me build it. This is my 1975 8-inch Newtonian reflector, sat on the driveway at our house in down near Portsmouth. You can see the homebrew arrangement made out of all sorts of bits of greenhouse and car wheel bearings making up the axis, and so on. I put this in because I took a photograph of Orion with it, which I've still got, and just wanted to show you that as a way of setting the scene. Here it is. It's not in the best of condition after all these years, but you can still recognize the 4 corner stars here and Orion's belt, these 3 across the middle, and the sword handle, and even see that perhaps the nebula there is not just a star. It's of course a photograph I took with a real film camera held up against the eyepiece of that 8-inch telescope, with a guess at the exposure, and then I had to develop the film myself in the school darkroom, because if you sent off a negative containing these sorts of images to the chemist, they would decide that there was nothing on them, or they would ruin them in the attempt to make it into an ordinary looking picture. So it just needed very careful developing. But it's amazing that the photograph has lasted as long as it has and still shows the same images there. Going back a little bit further, this is a star map from China from 700 AD, the Dunhuang star map. And we can see in the middle here that here is Orion's belt, look, and the corner stars marked out as well. So you can definitely make out Orion, and I think this is probably Sirius down here, but various other familiar star groupings that you can make out on it. So it's a very recognizable constellation and very widely studied and recorded. We've got a photograph that I took a little bit more recently than 1975. This one is the view from my back garden where my observatory is, with Orion riding high there just above the tree. And you can also see Sirius off to the left there, the very bright star just above the gatepost. But also visible is the scourge of astrophotography these days, which is the orange lights from the guided busway that's about 2 miles away down towards Swavesey. There's a bus station where they persist in putting the lights on and throwing all that nasty orange glow up into the sky. And that picture was taken with this little camera, the Nikon camera, just a 2 megapixel camera sat on the ground and just pointed up with about a 30-second exposure, I think it was. So a nice little image, just showing how prominent Orion always is. Easy to recognize. Slightly improved with a slightly better camera. This one belongs to my son, and again was taken with the camera on a tripod. You get a lot more depth of the image and a lot more color as well, and we start to see something interesting here, in that we can see most of the stars are very blue in color, except for the top left-hand star, Betelgeuse, which is an orangey white in this image. And then, of course, the Orion Nebula down here looking nice and pink colored. So a better camera with a bigger lens does a better job. Now we could use Orion to find our way around the sky. It's a very good signpost. We often navigate around the sky initially using the tail and the plow of Ursa Major to find our way to things like Polaris. But if you can see Orion, it immediately orients you because of the very prominent stars of Orion's belt. turn left downwards and you get to Sirius, go up and right, you get to Aldebaran in Taurus. You can go diagonally and find Castor and Pollux up there in Gemini, or you can turn left at the top corner and find your way to Procyon. So there are lots of different sort of ways of using that as a navigational aid. But again, we've got that same image here of Alpha Orionis, this orangey coloured star at the top left, Betelgeuse. And this is an actual image of the surface of Betelgeuse. Because it's such a large star, a red supergiant, and relatively close to the Earth at 640 light years, it's one of the very few stars where it's large enough, presenting a large enough angle that the best astronomical telescopes can now pick it up as a disk rather than a point of light. Having said that, we are not entirely sure how massive Betelgeuse is. It's somewhere between 7.7 and 20 times the mass of our sun. You see this symbol here, it means the mass of the thing in the middle of the solar system, M, and then the solar system symbol, i.e. the sun. So that's quite a wide range for a very familiar star. And it also means we're not entirely sure how old it is. If it's 20 solar masses, then it's 8 million years old. And if it's 7.7 solar masses, then it's 15 million years old, because that's how long it takes for stars of those masses to reach maturity and turn into these red giant phases. Now, in the future, that does make a difference, because if it's in the range at the bottom end there, 7.7 to 10.5, it won't explode as a traditional core collapse supernova, but will instead form a planetary nebula and a white dwarf. Whereas if it's above 10.5, then that's sufficient mass for the full core collapse to occur. So we're not entirely sure which way it's going to go. If it's up at the very high end of the mass range, then it's also very, very near that final core collapse. And every Wednesday when it's clear and we go out and do our observing, we check to see if it's blown up yet for that reason. But it's more likely to be another million years or more before anything extraordinary like that happens. However, it has been misbehaving during 2019 and 2020. It underwent a very strange dimming event. You can see the two photographs side by side here of Orion, and I think you can tell that Betelgeuse has become a lot fainter in colour. It's rivaling the star at the diagonally opposite corner in brightness, Rigel, down here in the first photograph for overall brightness. But now in this one, actually it's not even second, because Bellatrix here is probably brighter than Betelgeuse. And just zooming in and looking at it, there's a couple of high resolution photographs of the disk of Betelgeuse showing how its brightness had changed between just in a month, in a year, January 2019 and December 2019. And it looks like actually either there were very large star spots on the surface, or partly obscured by clouds of dust. And that cloud of dust could have been orbital dust, or it could have been dusty material being ejected off the surface. And that's something that these old stars tend to do when they're in their final stages. So it led us to think that maybe it was undergoing that beginnings of the process of either turning into a planetary nebula or going for a full supernova explosion. Here's the light curve of it, and you can see it dimmed down quite considerably here by going from magnitude 0.5 at the top to 1.5, which is a factor of 2.5 reduction in power output because of the strange way that stellar magnitudes work. But then in February of 2020, it actually brightened back up more or less to where it started and returned. So we're not quite sure what was going on, but there was definitely the detection of some dust. Now, having said that, it is a variable star, and we have partial data going back some time here, showing how the brightness of it ranges from about maximum peak of about 0.3 down to about 1 over the last 20 or so years, or over a 20-year period here. You can see how it does dim and brighten, but the dimming went even dimmer than usual. So perhaps a very extreme version of whatever it is that's causing the brightness here to cycle. At the other corner of Orion, you have the bright star Rigel. And this is, I'm afraid, not a photograph, but an artist's impression, but it's nevertheless a very good one. It's based on a photograph of the sun that they've colorized. But Rigel is a blue supergiant rather than a red supergiant. A little bit further away, 860 light years, and probably 8 million years old. And we know that a little bit more accurately because Rigel is a multi-star system, and we can plot the orbits of the B and C components, its smaller companions that orbit around it in periods around 24,000 years. And wherever you have a companion and you know the orbit, you can compute the orbit of the motion of these multi-star systems. Then, by use of Kepler's laws, you can work out the mass of the primary. And so we know that Rigel is at a mass of 21 solar masses, and that limits its age. It must be around 8 million years to be in the stage that it's at. Now, it's a blue giant because it is actively fusing helium in its core, whilst overlaying that there is a layer of hydrogen that is also undergoing fusion, followed by the outer envelope. And we can tell that it's doing that. There's a certain amount of dredge up that occurs, and we see not only helium at the surface, now enriched from the standard mix of 25% that was created in the Big Bang. It's up to 32% as Rigel has been making hydrogen into helium during its life. But we're also seeing carbon, nitrogen and oxygen formed in the process of that helium being fused to the next series of elements in this core. Looking ahead, it's going to cool slightly on its outer layers and become a yellow supergiant on its way then to becoming a red supergiant before finally dying in a core collapse type 2 supernova. And it's very interesting that when you see these giant stars that have gone beyond the ordinary main sequence and have started to fuse other elements, they can be in one of two states. They can be in a state where the core contains an element that is being actively fused upwards to the next element. So in this case, helium burning to carbon. Or they can be in a stage where the core is not yet hot enough to fuse whatever it's made of. So a slightly earlier stage would be an inert helium core, and the next stage is an inert carbon core once it's built enough carbon. So what's going to happen is as it builds more carbon in the core, it'll initially not be at a temperature that carbon can go undergo fusion, and so you have a dead core. And so the overall energy output compared to the overall mass of the star becomes less. And so the temperature cools, and it'll therefore go from blue to yellow and then on to red, until eventually the mass of that core and the pressure and temperature reaches the ignition point for carbon. And then what happens is the red stars shoot across the temperature range again, going through that yellow giant stage and back to becoming blue hot again while they have an active core. So if it's red like Betelgeuse, it has an inactive core, and if it's yellow or blue, then it's got an active one. This was a sort of discovery that I finally understood fairly recently. Looking at the other corner stars, Safe down at the bottom left-hand corner of Orion, also around 650 light years, so the same distance as Betelgeuse. 15.5 solar masses, again we know that rather precisely, and 11 million years old, so a little bit less massive than Rigel and slightly more slower burning, but it'll undergo that same evolutionary track. And top right, Bellatrix, and that is 244 light years from Earth, so it's that considerably nearer and lighter weight at 8.6 solar masses and 25 million years old. It's also in that post-main sequence stage and will evolve into a classical red giant, and then the yellow Cepheid variable stage when the helium core ignites and starts to form carbon, and then back to being a red asymptotic giant branch star, an AGB star, when it's building an inert carbon oxygen core. And then I think it's probably done for, because at 8.6 solar masses it can't really go any further, and that's also under that 10.5 solar mass limit, so this one won't undergo formation of a core collapse supernova and probably will yield a planetary nebula and quite a late stage highly developed white dwarf star, because it's nearing that limit, so it'll be a carbon neon type white dwarf star. So here we go back to a picture of the constellation of Orion. Just got Sirius sneaking onto the picture at the left hand side there. I'm just going to show you where a few of the objects that I like to look at in this part of the sky are. The first one, technically it's not actually in Orion, it's in the next door constellation of Monoceros, the unicorn, but as with most unicorns you can't find Monoceros, it has no bright stars in it, but it does have the unicorn's breath coming out of its mouth, which when you look at it with a telescope, or do what I've done here, which is use a long camera lens, a 300mm camera lens, riding piggyback on my main scope, so not looking through the telescope optics, just using the camera lens. And that's because this is an object that's 5 degrees across on the sky. The full moon would sit in this bubble in the center, and this bubble in the center is where the hot young stars are blowing away the remaining hydrogen gas out of which they formed. This was a star forming nebula about 15 million years ago. It's now just about at the point where no new stars are going to be formed, because the hot blue and white stars are blowing away the gas and reducing the density so that no new ones can be made. So that's the Rosette Nebula. Let's pop that back up there. And of course, the Orion Nebula itself, down there in the Orion Sword, this is again a piggyback camera shot. I quite like doing astrophotography just with the camera riding on top of the main scope. You can get some very nice wide field shots. So this is the whole of Orion's Sword with the nebula in the middle there. That's back into there. If we look at a little bit greater color depth here on this image of the Orion Nebula, we can bring a better view of it up here. This is the one that was on the title slide of this talk, and you can see how we've got the bright white stars in the middle lighting it all up, the dark dusty lanes here coming across in front, the extra little region here that looks like Pac-Man, but that's called M43. It doesn't have a common name itself, and all of the fine detail around the outside, bringing that up to full. There it is in all its glory, so you can really see how far out it goes. When you look with a small telescope like the 8-inch that I opened with, my homebrew telescope from 1985, with the eye, you tend to just see this bright bit in the middle here with the dark dust lane taking a chunk out of it. But the more powerful telescope, the further out you can see. So often you can see sort of a much larger region like this with maybe a 11 or 12-inch telescope. And of course, the camera sees more than the eye with this long exposure photographs. So we start to go way out to an extra distance. So it really does become quite a large object. It fills the field of view of my camera on the telescope. So we'll pop that back into Orion there where it comes from. Another view again with a wide angle telescope, different cameras. But this one, I put this on because a few years ago, I was visited by a professional photographer that Carolyn Crawford, Professor Carolyn at the Institute of Astronomy, was contacted by this chap who wanted to take some astro photographs, and she directed him to me, and it turned out he had real film from the leftovers from the photo reconnaissance people from World War II. And he had just a few reels of this infrared sensitive film for night photo reconnaissance. And he wanted to try taking some astrophotography images with it to see if it would work. So he brought the camera that worked with it around to my observatory, and we mounted it again, piggyback on the main telescope, and went for a bit of guesswork to try to take some pictures. And the following image I'm going to blend in here is the Orion Nebula taken in infrared light with the infrared film from 1945 vintage. And it was probably the one really good image that we got off a whole roll that we used, because we were guessing exactly what exposure to use and so on. You can actually see it's got more detail in it if I go back than the optical camera, digital camera image. So again, that lovely blend of the two of them, and then the nebula seems to get larger because the infrared film is picking up more of the cool gas around the outside. Now, if you dive right into the Orion Nebula with professional telescopes, the amount of detail that is in there is absolutely phenomenal. And here is just some of those cloudy regions, a few of the brighter stars, and lots of little regions labeled HH something. These are the very famous Herbig-Haro objects, and they've each been given a number here, so some of the numbers go into the 300s. What these are proto-stars that have been formed in the stellar nursery and are in the process of accreting in an accretion disk, whirling around, falling in, gradually building the star, and in some cases shooting out jets of material along their spin axes, which are creating some of these amazing structures that you can see. There's all sorts of different linear features within here and arcs and so on. Let's go in a little bit more detail on HH34. You zoom right in with the Hubble Space Telescope. The star is right in the center here, forming behind this very dense region of dust and gas out of which it's been born. And you can see the jet coming in this direction out from it to the right, and then forming a shock wave where the jet's energy is ploughing into the stationary matter of the dust cloud. And again, you can see the shock wave where the jet that's hidden is coming to a stop over here. And you can even see how it's been moving and spinning across space and leaving a trail of a shock wave behind. I think that's a fantastic image of star forming in motion. You can also see a lot of these protoplanetary disks where you have the star at a slightly more formed stage in the center, but nevertheless surrounded by the dust and gas of its birth nebula. And then in that protoplanetary disk, new solar systems of planets are still in the process of gathering together and forming. There's dozens of these in the Orion Nebula that we can now see, and you can imagine how these are going to turn into different planetary systems. Some of these down at the bottom are seen edge on, so you can see the dust that is going to form a flat plane of a solar system in these ones here quite easily. Others, we've got a more of a polar view, so we're looking down on the star and you can see into the center where the star is and the ring of dusty material around it. So you can put all of that information together and confirm what we're saying about the way that planets form in these rings around stars. Now here we've got the very famous Horsehead Nebula, a dirty, dusty, swirling cloud of gas here moving across in front of some glowing gas in the background. And we've got the Flame Nebula up here. The Flame Nebula and the background gas are being lit by the powerful ultraviolet light coming from this bright star here. This is Alnitak, and it's the left-hand star of Orion's belt. So these other gas regions are at the same distance from us as Alnitak, and the Horsehead Nebula is a little bit nearer. Also notable are some of these other bright stars in this little cluster here. These are also very hot white young stars. So there's a bit more detail on the Horsehead Nebula and the Flame Nebula, some photos that I took here, and another wider shot in color. So there's Alnitak, and you could see actually where my telescope wasn't perfectly collimated, because that out of focus ring should be right around the middle of the star, not off to one side. So the mirror had moved a little bit. But nevertheless, the Flame Nebula on its side down here, and the color shows that red color from the emission line of hydrogen at 656.28 nanometers, the hydrogen alpha line. And again, the same color for this ribbon of gas here and the lovely Horsehead Nebula. Also in Orion, we have another type of nebula, again associated with a hot blue star. This is Messier's object number 78, not one of my photos. This is a professional one. The star itself has formed inside this cloud of gas, and you can't see it because it's behind this really thick, dense region here. But it's blown a bubble, a cave inside where it's formed, pushing the material away with its radiation pressure, and it's lighting up the inside of the cave with its blue-white light due to its very high temperature, and we're seeing that light bouncing back to us. It's called a reflection nebula, and this is another one. This is called the Witchhead Nebula, and it's part of a band of material that is glowing in the reflected light of that blue supergiant Rigel down at the bottom right-hand corner of Orion. Looks a little bit like a face. We've got the big nose here, pointy nose, mouth, chin, and the eye sockets up here, and part of the chest here. It's a very large object, actually, again, several degrees across, so quite difficult to photograph. If the telescope you're using has got a long focal length, then you can't get the whole thing in one go. But here's Orion's belt in true glory with the three belt stars. And again, down here we've got Alnitak with the Flame Nebula. Actually, the Horsehead Nebula is hiding behind the banner there, but there's that streamer of hydrogen. So Alnitak, Alnilam, and Mintaka, the three stars of Orion's belt. And they're often overlooked because the attention is always given to Betelgeuse and Rigel. But these three stars, nevertheless, really quite interesting systems in their own right. So if we go to the top right one, Mintaka, turns out this is a quintuple star system, and it's got some very massive blue stars in it. You can see the solar masses listed there. AA1, so the most powerful component, 24 solar masses, AB at 22.5 and AA2 at 8 solar masses, are all fairly large stars. And then there's one that for some reason hasn't got itself a proper designation yet, must have been fairly recently discovered, another 9 solar mass star, also a blue-white giant. Round about 8 million years old. Again, we know that from the evolved state of the larger stars in the group. And it's 1,200 light years away, so it's actually twice as far away as the likes of Betelgeuse and Safe and Bellatrix is quite a lot nearer. And that's why we don't see it as the brightest star in Orion, because with the power output of this lot, if it was at the same distance, it would be very bright indeed. And it's also got just one little tiny extra companion that's about 60% the mass of our sun, orbiting around with these enormous giants. So anybody living on planets around this star here is going to be in for a rude shock when all 4 of these blow up, or at least 2 of them are going to blow up as enormous type 2 core collapse supernovae, and the other 2 are going to explode out to be red giants and give off their outer layers as planetary nebulae due to their slightly reduced mass. Alni Lam, though, in the center of Orion's belt, is even larger. Because it's single, we don't know its mass very accurately, but it's somewhere in the range 30 to 65 solar masses, and it's even further away at 2,000 light years. And we're guessing its age at about 5 million years. That's on the basis that it's at 30 solar masses. If it was 65 solar masses, it probably wouldn't last more than 1 million years in its total lifetime, because the lifetime of a star reduces very, very rapidly with the increasing mass. It's related really to the inverse square of the mass, or possibly even a little worse. So this is a real monster star, and we often talk about Betelgeuse being due to explode as a supernova. There's every chance that Alni Lam will beat it to it because of its higher mass and therefore much shorter lifetime. And finally, Alnitak, the one that's next to those nebulae that we looked at, again photograph here with the Flame Nebula going out to much greater detail. This is also a triple star system with a 33 solar mass monster, a 14 solar mass, and another 33 solar mass monster. So again, these are 1,200 light years plus away. That's why they're not as bright as the nearer components of Orion, and around about 6 to 7 million years old. So again, heading towards the late stage. It won't be long before they start undergoing the final stages, going through the yellow and red giants and supergiant stages, and then blowing up as core collapse. And I just want to look further at one more point about Orion's belt, and that is the hypothetical connection, as potentially unproven, that the pyramids of Giza in Egypt have got something to do with the layout on the ground of them, something to do with the stars of Orion's belt. There's a curious coincidence. Here's an aerial view of those pyramids with the slight kink in the line here. They're not absolutely straight, and the distance between them matches up really rather well with the placement of the 3 stars of Orion's belt. And it's interesting in that probably 5,000 years ago or more, when the pyramids were being built, it's possible that they'd moved slightly, and even that Mintaka wasn't quite as bright as the other 2, and as potentially explains rather why the 3rd pyramid there is a bit smaller. And various people have also suggested that the placement of this and certain other pyramids within the region that are outliers line up with the other corner stars of Orion, and that the way that the River Nile runs down the side of Orion might also be, the River Nile runs down the side of the pyramids, and their placement relative to it might also be significant, because this is a very deep photograph of Orion showing a feature called Barnard's Loop here, running down this side here in this curve, which is a very large streamer of hydrogen gas. And so if the Egyptians had very sharp eyes and they would have had no light pollution problems, they would probably been able to see this. And maybe this is represented on the ground as the River Nile relative to these three stars, and they placed their pyramids accordingly. Of course, this is hypothetical. We don't really know if it's related in that same way, but it's an intriguing correspondence. I love this photograph because it shows down the Orion Nebula down here. This is the Witch Head Nebula that I showed you, lit up by the light of Rigel here. So quite a long distance between them, but nevertheless, it is reflecting back that light, and tremendous detail in these images. So I do hope you all get a chance to get out there with your binoculars and try and track down some of these lovely sights in Orion, or a telescope if you've got one. And I recommend using a camera mounted piggyback with a wide angle lens as a way to take some really lovely shots like this one. It's absolutely fantastic the way that some of the detail comes out. And there is the whole of the constellation with that lovely Barnard's Loop in it. Here's Betelgeuse at the top, Rigel at the bottom, and this huge cloud of hydrogen surrounding all of these little tiny extra star cluster members, which is kind of Orion's head up at the top here. So you can see there's just so much more you can go and discover. So thank you very much. I hope you've enjoyed that, and do get out and do some stargazing. It looks like it might be clear here this evening, so I might have a go myself.